Right folks, this isn't a customer repair, this is trying to get a scrap chassis working, and it's a Harvard Good Buddy. This is a special request, so I've got a choice of 3 scrap chassis as we've bought them. There we go, one without a channel knob. That looks more, it's had some shenanigans around there. I don't think that's going to be any hope. It's had its channel selector, it's had its phase lock loop chip and a lot of fancy people taking presets out. They're always knackered anyway. Just buy new ones. So that might be a source of some parts. And then this one, they've had the socket off the back, but of course we're down to the 2-pin socket. That looks complete. No, it's had a coil nicked. So we've only got one we can be playing with, I think. I was going to play a game called Compare the Serial Numbers, but they haven't all got serial numbers. So 9705 and 892011. Good grief, that's a long number, isn't it? I remember these selling at £18.95. Yes, £18.95, folks. Right. I think they're a weird mic pin. So it's not so much that they're a crap set, it's that they are unreliable. And one of the queries from one of the viewers is that when he puts his into channel 9, the display goes out, and it may be that that's what happens. I do have the circuit diagram because I bought one brand new at the time. It came with the instruction book, and it came with the circuit diagram in the back of the instruction book, which at least is handy. So without looking at the channel 9 switch arrangement, we'll come to that later. So they're a messy set, an untidy set. Not sure why you have a choke and a transformer. It's like it's an AM bit, but it isn't. So it's an LC7136, or I think that's the only synthesizer I've seen in them, which is the fatter version of the 7137. But I don't know if we're going to get anywhere with this, and it may be possible that I've got others in my shed. My shed is full of shelves, steel shelf units, and the shelf units have those plastic very useful boxes on with the lids, and we have scrap chassis in those plastic bins, so they're not open to mice and that, which is good. Right, so if we get this working, we haven't got any lids, but we'll probably see what we can do. So the first problem is we can't get the power connector. So we've been down that avenue, and hopefully I've got a pins thing. We might, if we could be bothered to file it out and put a different one in, couldn't we? So which one's positive and which one's negative? Well, the set's so corroded. Oh, guess what? There's a red one and there's a black one. It's wider than I was expecting. We'll use the crocodile clip lead. So we do have some other sets in for service. They include one of those Mega Tracker CB1100s with no receive. Never worked on one of those. But it does say it transmits, so we've got a possible fighting chance. So we lit up and it's on channel 20. The fact it's on channel 20 tells me that at one point we did look into this set. Let's press the channel 9 switch, and it says 9 on the display. So if Yours doesn't say 9 on the display, mate. There is a fault. Okay, well, the switch will go to a diode matrix. And the diode matrix will be on the channel selector board. Right, we'll connect our tannoy speaker and we'll put it into PA. At least they have PA. The fact it has a red sticker on the back means that Mark has tested it and it's no good. So if we look at our general mic thing, I don't think it's a... I think it's a unique mic. Harvard Good Buddies pin out 8. Pin out 8. It's like Uniden, but audio and screen reversed. So there's Uniden, and there's Harvard Bad Buddy. So you've got PTT and receive, and then audio and screen reversed. I'll go and see what we've got in mics, if there's anything with no plug on the end. So I found a nice microphone which hasn't got any badges on it, but it's got one with a properly screened lead, unlike some of these cheap Chinese ones. So this has been previously wired to Cybernet. So all we've got to do with that is to move transmit and receive around. So we'll get rid of that one, unsolder that one, and put the red one where the black one had been, which on these mics is hopefully transmit, and the black one where the red one has been. And that should be all we have to do. So now we've got receive, transmit, screen, audio. Receive, transmit, screen, audio. And as long as it's been wired inside correctly, we're all right. So either a Cybernet mic with 2 wire changes or a Uniden mic with the opposite 2 wire changes is a quick rewire. I'll label this unless we find a case and we sell it. Not forgetting the teeny weeny screw. There we go. So that should be the correct wiring. Now, I've observed something. Why would somebody put this purple wire through its choke to earth? So if we follow the purple wire, it goes to mic socket, speaker socket, and it does on this other one. And when we follow the purple wire to this set, it actually goes to the second pin down on the mic. Lo and behold, the second pin down on this one's mic doesn't appear to go anywhere. No, it doesn't. So someone has taken that off and put it to chassis, probably to get... I bet that's the receive pin, and putting this to chassis would enable the set to receive. It's a bit awful, isn't it? Right, mind you, the whole sets are a bit awful. Never mind, Alan sent us a Fidelity 1000 to fix, so I've got something half decent. At least you know they're reliable and they transmit nicely. And as long as you're not in a city, they work alright. Trying not to melt the other wires with the soldering iron. So that like that would stop. I would think the radio would be in transmit and receive at the same time, which would be a bit weird. It's just what I think. I'm glad I got another set to kind of notice that. Right, we'll power it back up again. I just need to. This is going to be the pain, isn't it? If we get it going, we might do something about this. So there we are, 350 milliamps. Let's switch it to PA. Would we expect anything to work? Alright, we'll put it in CB mode instead. We'll connect the test equipment. Switch picture in picture on, and it transmits. It transmits on frequency. It's doing 1.2 watts. It's on low power. Switch it to normal. It's doing 1.2 watts. Oh well, does it receive? Yep. Sounds awful, but there's 100, that should be S9. Listen to all that heterodyning as we go down. Squelch is so coarse that it doesn't ever open on full. So the set's more or less working, isn't it, apart from on PA? So let's see if we've got any transmitted audio. Voila, we have. We'll get our talkie-walkie, last used on that Binatone handheld. Testing 1 2, testing 1 2. Oh, we're on channel 31 hour, you silly fool. Testing 1 2, testing 1 2. Sounds absolutely fine. Okay, well, I wasn't expecting that. I was expecting to do quite a lot more to that. But why isn't it working in PA? Has somebody linked the PA switch out? I think somebody has. It's the kind of thing people do. Perhaps we're going to turn it into something else and then realised that that was futile. So on this set, yeah, we have no, I don't know, we've got a white and a red on the same connections there. Perhaps that one's had the PA disabled. It's possible the switches are so crap on these that this is what people do. But on this one, this hasn't. And it's got the LC7137 on this one. So we bought this in as a scrap chassis 15 years ago, whatever. It's been on the shelf. None of these are recent sets. This chassis appears in the Alba CBM5. We've got one of those, or we've got the Harvard H404, which came in that batch from Lancashire. So we will be doing that in due course, and flogging it, because we only bought those to kind of do these demonstrations. Yeah, well, so we should have blue and white on the right hand pole. We've got blue and blue, and then we should have blue and white and red somewhere. They've just used whatever colour wires to hand. It's no, there's nothing. There's no trouble gone into this. I may find another scrapper in the shed, and we'll worry about the PA. I mean, we don't even need to worry about the PA, but I like these things to work when they can, but you can't always. Person with the channel 9 not showing, so he said it was working on channel 9, but it doesn't show it on the display. So you've got a double pole, you've got a triple pole switch, and it's quite possible that wiring's been linked out on the back. All you can do is compare. It's also possible the switch is simply dirty. So we're going to have to come up with I think we've covered these before, but I'm not going to bother looking in the back catalogue. I'll go and have my lunch. We'll make a very quick start on this. It's got the red sticker on the back, which it has. We bought it probably around 2005. And it probably packed in working within a year of being purchased, because they're not reliable. Not helped by all these bits of wiring. I've never had any capacitors go down. So the first thing we can do is put it on frequency. So let's go over to our frequency counter. $27,79104. So it is on frequency. It's just me trying to get it a bit more exact. I will do a photo and all that just for future reference, because of me doing that Albaror Harvard one which we bought from Lancashire. Don't, if you've got one, it's not quite doing 4 watts. If it's, you know, if it's doing 3.2, leave it, because this is all part of the. They're just not a nicely made set. You just don't want to be thrashing them. And these are another set which could well start playing RF feedback. These came a bit later, like 1982, 1983. They weren't 1981 sets. Hong Kong, no, Korea. Right, we don't have a VCO method, and we'd have to work something out if we ever came up to that. At a test point, no, it's a capacitor. So, looking at this, we won't touch those two. That's going to be VCO, and I think we're going to have the transmit's going to be there. Don't know whether that is, could be, and then into the PA. Put a nice cracked core in that. Let's see what we can do. I won't touch that one. And what we'll just do is show you the power meter. So we're on high power, but it's not very high, is it? Has the switch been linked out? I don't know. I think it has. I think the wiring's long gone. It's set up. It could be full power only. So this tells us how unreliable the switches are. At maximum. That's at maximum. And that's at maximum 1.3 watts. I can't see any silly stretched coils. This filter's poor show round here. Compare that to the scrapper. Unless, of course, they've linked it to low power, and it's actually on low power all the time. So where is the low power preset? Well, VR2 is going to be meter. VR3 is going to be RX meter. VR6 is going to be squelch. Here's a process of elimination. VR5 yeah, they use a modulation transformer to apply the audio. How bizarre. It's deviation. So by process process of elimination, actually 10 dB attenuator is shown as an afterthought. So, very quick look at what we've got. We've got VR6, so that's going to be squelch. We've got VR3, which is going to be receive meter. We've got VR7 by the looks of it. I can't know, it isn't. Looks like VR1. Oh, that looks like it should be deviation. We've got one I can't see the number of, but because we've got this one with it removed, we can see the number. It's VR5, which is deviation. It's next to that modulation transformer, which is bizarre. So that will be deviation. So what's this? Let's key it up and see what happens. Nothing. Let's talk into it and see if anything happens. Walla. That's deviation. Well, what's this then? Walla. That's also deviation. So that must be kind of left over from modulation depth if it was an AM version. So you've got that and that for deviation, which is daft. We've got a preset there, and that is VR2. So that's going to be the TX meter. So VR, whatever we said, that one there, VR5 is VR5 and this front one. VR1. VR1 and VR5 is deviation. I think that's depth. And that's actually deviation itself. So, I don't think we must have got low power somewhere. Is it VR? No, it's not that one. So we've covered 1, 2, 3, 4, 5 presets. 1, 2, 3, 4, 5 presets. So if it has low power, it's done on a preset dropper resistor, which is probably that one at the back. It's had work round the PA, so we're going to have to look whether that's been implemented right. I'll come back to this after lunch. I'm surprised we've got anything out of it. So I've just had a look in our storage shed. I did come up against another one which has been robbed but does have its channel selector, and we can have a look at the wiring once again. I was hoping to find a case, but I think all cases have ended up in skips over the years. So if anyone's got a case they want to sell, can always email me. And this one looks intact. We've got blue to the bottom, red to the middle, and red and white to the top. I'll turn this set off. So red and white to the top. I'm not going to. The switch has been rewired to eliminate PA, so I'm not going to take the front off to get down to it properly on a set worth nothing. And even if we sold that, it's still worth so little. It would have been nicer to see PA work, but I don't think there's any hope in that happening. I don't know whether that's build-upable. I don't think so. It's not like it's a Rotel 230 or something. So it's doing less transmit power than we would expect. So what is the voltage? I'm just wondering if when they've linked out the high-low power switch, whether they've actually linked it to low power. Or whether it just happens to be a bit of a 10-1 set. There's a good phrase. Anyway, we'll look at the receiver. Sounds awful. So we'll plug our cyanide meter in. Microvolt for 12 dB. I did look at the instruction book while I was looking on my computer to print that off, and it's supposed to do 0.5 microvolts for 10 dB, and right now this is doing 0.7, so it's out of spec, and it says on the thing less than 4 watts for the transmitter. Now that's ambiguous, isn't it? You know, it's like the Great chassis being a 3.5 watt chassis. Will it do 20 dB? Actually it will, which is more than some sets will. It'll do it for 5, 6, 7, 8 microvolts. It's only noise, it doesn't matter. Never opens. And I think that pot's a bit noisy. $100 microvolts. 95 microvolts to open squelch threshold. I'm hoping the IF's out. That would be useless. Right, so we'll have a look at the receiver, we'll put the oscilloscope on, put 100 microvolts on the signal generator, and we'll go over to the oscilloscope. So where's our detector? It must be hiding somewhere. It's T16. It's not conventional, this. It's going to be T16. And that's 15. and that's 16. Let's have a look what happens. It was already spot on. So that's not our anomaly. Let's turn that squelch down, it's coming. Right, we'll go to the cyanide meter. Just going to see whether this is what's playing up. So the front end, I'm assuming it starts. Let's have a look where it does start. T1, T3. So that's T2. There's T5, 4. So that's on the. That one is on the receive, which is why we weren't having anything happen on transmit. So 3, 4, 5, and 6 are definitely receive. That's 2. And then we have 17. We've got those two there. 12, 11 and 12. Fourteen and 15. That's 3. So that's actually where the receiver starts, not where I thought the transmitter was. So I'm just going back into transmit. Put the cyanide meter up. I'll just go back into transmit, and because I thought it made some difference. Eleven, 12, 13, 14, 15. There we go. That's 9. 10. 9, 10, already lost 11, They're those down there, aren't they? 11 and 12. Improvement there. Drop the attenuator off. Bigger signal for these. Smaller signal, can't see them moving. Just go back to the detector. Might have to put a secondary signal generator on to just peak those. Let's see what we're getting first. So we've now got 0.5 for 12 dB. So it's better than the manual says. So 0.44. And 20, 3. But have we got any better squelch action? Let's go back to a speaker ignore here. It's nasty, it's got artifacts. Just clean this control though, if they're the type which can be. At 30 microvolts, dreadful, unusable. So the squelch preset we came to the conclusion was VR6. No, it's 85 microvolts to open the squelch, so there's going to be something wrong with the IF. So we'll get our secondary signal generator. Turn this back off. Just go back to the sound ammeter. Massive difference. Just look where we are now, whether it's better or worse. Go to 455 just for a laugh. It's in the memory somewhere. No, it's not out at all. Right, we'll go back, we'll take that off. Go back to normal. See what we've got now. So 0.75 microvolts to 12, so we're getting it worse. But is it responding on squelch? Go back to the speaker we can hear. I've gone through it and through it and through it. I've compared between the squelch and the IFs and so on, and I think we're there. So let's see what the sensitivity is first before we see whether the squelch actions, and then we'll go to the other speaker. So we've now got 0.6 of a microvolt. So 0.6, and then we've got for 10 dB 0.5, which is exactly what the book says, and then for 20 we've got 2.8. Right, let's go to the normal speaker, which we can all hear. We've not got any silly artifacts. All the IF was screwed up, and we've had to use the second signal generator to unscrew that. So, squelch. Signal generator off. Let's go to the attenuator. Set to squelch. Signal generator is parked at 0.3 of a microvolt. Switch it on. That go was 2.8. Let's give it another go. See if I can be more careful. Threshold. .8. And maximum squelch. Isn't far off where I'd like it to be. It's 300. Right. Well, we got there. So, what have we got left? The meter. So 100 microvolts. Turn the squelch down. So where should it be? It's 9, isn't it, up there? So the receive meter is VR3. Especially if you don't disconnect the power. Slightly dirty. Actually doesn't ever go beyond 8. Transmit. Well, of course it's not doing the right power, is it? It's saying we're doing all those watts, but we're not. So I just want to see what it hears like. Let's put it on the aerial. At least it now sounds normal. One, Anna Roger. Well, we actually heard it somebody say, yes, usual chatter. So that proves something, doesn't it? Let's go back to the test instruments. See whether we can get anything more than 1.7 watts out of it and why that is. So we should have an orange wire to the centre and a red wire to the top. So orange to the centre and red to the top, but they seem to be random colours, so they don't seem to follow any standard thing. So what have we got on this? We've got something to the top. We've got absolutely nothing to the bottom. And I can see a snapped wire. There we go. Now, how we can get this soldered back on is another thing altogether. And the wires in these are so weak. You know, if you it's like the gentleman who says he's got no channel 9 coming up. Don't take the front off, you'll snap half the wires. You know, it's just not worth it. I'm only doing this because I'd like to see it do more than 2 watts. And if I melt some of these wires, well, I melt some of these wires. I just daren't part this any further. But I think if these are undisturbed, they'd probably work alright. Well, as alright as they ever did. So that is successfully soldered on there. So I'll put one screw in and then try and get the other side. So something's stopping it. There we go, just sharp rubbishness. One of the screws went inside the set and it hasn't come out yet. It'll come out in a puff of smoke in a moment. There we are, that's it. Out you come. So remember, it was jammed between transmit and receive because someone had taken the wire off and put it to earth so it would receive all the time. Let's see what happens now. So we're in normal. So having rewired the high-low power switch, the person who had wired it to link it out, clearly the switch was iffy, I've cleaned the switch, they've linked it to permanent low power instead of permanent high power. Right, let's see what happens if we can just tune the transmitter up a bit more than the 1.2 watts we were getting before. Now we did see 2.5 watts, and that's when I turned the low power preset, which is this additional one, this afterthought. When I turned that, we did get 2.5 watts in the low power setting, but we can't set 0.4, it's a bit high. .6 and a bit. Whoa, there she blows. I've got to tune it up to tune it down. It's gone over the 4 watts. There's a lot of current to draw through that switch. So it just managed about 4.2 watts. I'm just going to check it on the other channels. I don't want to turn the setup to face you. Channel 1 is 3.8 watts. Channel 40 is 3.2 watts. See whether we can just improve that a little bit. 3.4 on channel 40. 3.9 on channel 1. 4.05 on channel 20. So we've seen better, but considering, so 4.05, I've already forgotten what I've said, and now it'll have cooled down. Channel 1, we could say 3.95 on channel 1, and channel 40, 3.5. So when we go to channel 31 to do our test, it's going to be doing spot on 4 watts. Good. Current consumption is now 1.2 amps, and low power we'll now try and set now. The thing's tuned right, this is working properly. .400 milliwatts. Now going back to high power, 4 watts. Good. We're going to double check deviation. It looked right. It was about, well, it was somewhere at 2.7. I'll check with the test set behind because this tends to lie. Check we're still on somewhere on frequency. We are. So, RF meter is all we've got left. So, key it up, bang. It's the preset down there. Centre of the red zone. I do like the vertical meter. I just wish it had a better quality set behind it. And you know, some people have had these from new. They've had them 40 years and they love them. And I think if they're not disturbed, they got, you know, one that actually works will probably carry on working for a very long time. It's just, if people fancy themselves as the golden screwdriver expert, they're just so badly made that the slightest move and the wires snap. And switch quality, you know, it is an issue with them. Right, we'll plug this now into our quartz lock test set behind me, and we'll just see what the deviation is. Wow. Right, okay. It's well, it's beyond what our machine will even read. It was like 14 or something like that. Wallow. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. Let's just listen to that because I can hear it popping away. 1 2 3 4 5 5 4 3 2 1 1 2 3. So that seems to be the best point. Oh dear, it's awful. 1 2 1 2 1 2. Just to recheck the deviation. Now I've altered that depthy thing. Wallow. Wallow. 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5 5 4 3 2 1. Wallow. 1 2 1 2. Yeah. So we've got 2.2. It's actually 14 kilohertz. 2.2 to 2.5. Right, folks, put it on the aerial. Behind the scenes, when we put this away after the on-the-air test, I will solder the screen plate, which I recovered off one of the other scrap sets, because they're all scrap sets. And the accountant will say, and what was your production today? Oh, I did a complete rebuild. And how much money will we be taking? Nothing. It's a scrap chassis of our own. And he'll probably say, well, I think you need to be getting a job at the chip shop. One Anna Roger.
They monitor how she's getting on, and I think the school 8 or half past before we actually got done because he got took. That's it. Yeah, Rich.
19 a Roger. Well, you know what? We don't often hear two conversations, do we? So it's done better than most sets. Sensitivity, we ended up at 0.6 of a microvolt, and the manufacturer says 0.5 of a microvolt for 10 dB, which is exactly what we got. So it's absolutely on the money. So that's it. That's how we're going to be presenting it. Yeah, right. Thanks for watching the Harvard Good Buddy H403 Resurrection of a Scrap Chassis. And if anybody's got some lids for us to buy, we could make up a complete set.